Petrol or diesel internal combustion engines convert calorific energy into mechanical energy during a four-stroke cycle. Whatever the engine type, the crankshaft must rotate 2 turns, i.e. 720 degrees, to perform one complete cycle. A stroke is completed in 1/2 turn of the crankshaft, 180 degrees. In order to run, the engine needs an explosive mixture consisting of petrol or diesel and oxygen present in the air. The engine operates according to the following cycle. Intake of the air-fuel mixture, induction. Compression. Ignition of the mixture. Combustion, power stroke. And exhaust. In a diesel engine, combustion of the mixture is by simple compression followed by an injection of diesel fuel. By contrast, the ignition for petrol engines is via a spark. Diesel engines are known as self-ignition engines. Click on the key. Engine operation takes place according to the following cycle. Intake, induction. Compression. Injection of diesel fuel. Combustion, power stroke. And exhaust. First, let's take a look at the first phase of the cycle, the intake, induction stroke. The piston descent creates a vacuum which draws in the mixture or the air through the open inlet valve. During this stroke, the exhaust valve is closed. The piston reaches the bottom dead center and the inlet valve closes. The second stroke is the compression. The 2 valves are closed. The piston ascends to the top dead center. The mixture is then compressed inside the combustion chamber. The compressed mixture heats up. The third stroke is the combustion, power stroke phase. Click on the key. The 2 valves are still closed. The piston is at top dead center. The mixture ignites. The ignition pushes the piston downwards. This is the power stroke. The calorific energy is converted into mechanical energy. The 4-stroke cycle is completed by the exhaust stroke. Once the piston has reached the bottom dead center, the exhaust valve opens. The piston ascends and drives out the burnt gases. The inlet valve is still closed. When the piston returns to the top dead center, the exhaust valve closes and the cycle starts again. In a 4-cylinder engine, the cycles of intake, induction, compression, combustion power stroke, and exhaust are sequenced over each cylinder. The timing synchronizes the movement of the camshafts and the crankshaft. The pistons are displaced sequentially, assuring continuity of the crankshaft rotation. The opening and closing of the valves is synchronized in relation to the movement of the pistons. The points of opening and closing of the valves in the 4-stroke cycle seen previously are theoretical. In reality, the opening and closing of the valves is sequenced to optimize engine performance. The timing diagram represents the valve opening advance values and the valve closing retard values. In this section, we covered the following points. Internal combustion engines convert calorific energy into mechanical energy. This is the 4-stroke cycle. In a diesel engine, combustion of the mixture is done by simple compression followed by an injection of diesel fuel. The mixture, or the air, enters the cylinder via the inlet valve. With the valves closed, the piston ascends and compresses the mixture inside the combustion chamber. During combustion, the compressed mixture ignites. The calorific energy is converted into mechanical energy. The four-stroke cycle is completed by the exhaust stroke. The cycles are sequenced over each cylinder. The pistons are displaced sequentially, assuring continuity of the crankshaft rotation. The timing diagram represents the valve opening advance values and the valve closing retard values.